Hello student, the question says a point charge plus 10 microcoulomb is a distance 5 centimeter directly above the center of a square of side 10 centimeters as shown in figure 1.34. I think it is figure 1.31 in NCERT. There could be a mistake here. It is figure 1.31. What is the magnitude of electric flux through the square? Think of the square as one of the face of a cube with edge 10 centimeter. So let us see this question. There was a side, one of the edge, like one face of a cube is given. We know cube has 6 faces. One of the faces of the cube is given, and there was a charge lying at a distance of 5 centimeters from the center of the square. Now we need to use Gauss law to find the magnitude of electric flux through this. So before we use Gauss law, so this is the given question. Even the exactly it is not given properly in the NCERT. This is a better way to understand it. There is one side, imagine a floor, and we have a charge at a height from it. And we know to apply Gauss law, we need to enclose this surface. Enclose the charge. Like, what do you mean by we need to enclose the charge? Okay, so what is basically Gauss law says? Gauss law says integral of E bar dot dA bar is equals to charge enclosed by epsilon naught. Right now I will not explain much detail about the Gauss law. The only thing you need to understand is, suppose if you have a charge and you need to apply Gauss law, first you have to surround this three-dimensionally. That means you have to surround this in all the directions. This is a charge. Now I surround it on all the directions. You can take any shape and surround it. You can even draw a sphere around it and surround it. So if you have a charge, the first thing generally to apply a Gauss law, we have to surround it in all the directions. Only by surrounding it in all the directions, we need to apply Gauss law. And how should I surround it? Should I surround it with a cube? Should I surround it with a sphere? It depends from case to case. But generally, we either select a cylinder, we either select a cube, or either we select a sphere while surrounding a charge. Now, if you notice this charge is not surrounded on all the sides. This has only one face, it is not surrounded on all the sides. So to apply the Gauss law, the first step we have to do is we have to surround this on all the sides. So I will draw an imaginary sphere around it, imaginary cube around it. So this is one cube. So this is another face. I'm slowly drawing it. And then so this may not exactly look like a cube, but just think that I have surrounded this on all the sides. This is like in the middle of your row. So once we have surrounded this in all the sides, we can say total flux through this surface, like whatever the surface, this is nothing but flux, so is equals to charge enclosed by epsilon naught. What is the charge that is enclosed? There is only one charge in this surface, so the only charge is q, so it would be q by epsilon naught. Now if you notice it, every side of the cube every face of the cube is at equal distance on all the sides. It is at equal distance from this side, it is at equal distance from this side and this side, and it is at equal distance from all the sides. So we can say the flux from each side, they will actually divide this q by epsilon naught into 6 parts. That means, let me call this 1, 2, 3, 4 and 5, and the forward one would be 6, like the front one. Okay, so we have 6 faces. Each face is at equal distance from the charge. So each side or each face would divide this equally. So we can say flux through each face is equals to 1 by 6 q by epsilon naught. Through the entire cubical surface. This is through entire cube. But for each phase, there are 6 phases. For each phase, it would be 1 by 6 q by epsilon naught, as they are at equal distance and they are enclosing equally. I hope you understood how we got this. Now let us just substitute it. So flux through each phase is equals to 1 by 6 q by epsilon naught. So 1 by 6 epsilon naught value is 8.85 into 10 power minus 12 into charge value is 10 into 10 power minus 6. Now, once we solve this using calculator, we'll get 0.0188 into 10 power 7, and I can write this as 1.88 into 10 power 5 Newton per coulomb into meter square. So the units of this are Newton per coulomb into meter square. If you notice it, flux formula is B E into E. Electric field into area. Electric field units are Newton per coulomb. Area units are meter square. So this is how you can easily remember the units of flux. So this is the value that you will get. Now, if you try to see this value behind NCERT, you will notice that this value is not given. Why? Because there is a mistake in NCERT. So in the NCERT solutions, you won't find this value. The reason is that in NCERT, answer of 1.17 is given under 1.18, and 1.18 answer under 1.17. So if you see the solutions, you will understand it what I am talking about. Basically, some printing error, the answers were flipped. But anyway, again, I will explain it a little bit. Whenever you need flux through a side, or whenever you need a flux through the entire space, first thing we use Gauss law. And while using Gauss law, we surround the body on all the sides. Once we surround the body on all the sides, so to surround it, this is one side of a square. We have constructed in imaginary squares. So once you surround on all the sides, flux is charge enclosed by epsilon naught. So on each face, since we have 6 faces, on each face it is 1 by 6 q by epsilon naught. Substituted everything. Remember, the same question could be asked for entire cube also. For the entire cube, it is still q by epsilon naught. For each face, it is 1 by 6 q by epsilon naught. Hope you understood. Thank you.